is the average rate of change? Well, to do that, let's go back to the calculator. And while I've got this function up, I want to remind everybody that we called F1, our volume expression is F1. I'm going to switch to the calculator mode, and I want to do this in one step. So remember, it was the change in the y value. So to start my numerator, parentheses, F1 of 14.5 minus F1 of 13.2. I want to take that whole expression and divide it by 14.5 minus 13.2. I'll give you a moment to catch up here. F1 represents the volume formula. The volume at 14.5 minus the volume at 13.2 divided by 14.5 minus 13.2. I'm going to hit enter, and let's make sure everything's okay here. This is exactly the way I want to see the answer. Change in y over change in x. Now I need to pause, and I realize that I have an issue happening here on my computer. According to my computer, the answer is negative 154.58. Now, I don't know if my computer is giving me a fully accurate answer. In order to fix this, what we're going to do is we're going to go to Menu. Actually, we're going to go to the home screen. Sorry. We're going to go to Settings. We're going to go to Document Settings. Here's the problem. I don't want to be in float mode. I want to be in fix mode. And I like to see more decimal places. So I'm going to say fix 6. My angle is fine. The exponential format, I want that in normal. Okay, everything else is good. I want to make this the default. Yes. So now if I go back to the calculate screen and I select this expression again, there we go. I'm getting negative 154.580000. So I have confidence now that this negative 154.58 was an exact answer, but with the TI Inspire, you really want to make sure that you're carrying as much decimal point accuracy as possible. And this is a standard that we hold students to on all of our unit tests and trimester exams. So let's take this answer and let's write it down. So we know from our calculation that the answer is negative 154.58. So let's write the sentence now. And I know the sentence is something that we still struggle with. So we're going to say from x equals 13.2 to x equals 14.5. These x values represent the inches. So we first mention the interval. Secondly, we have to mention the function. The function here is the volume of the box. So we mention V. That's the second thing. Third thing we mention is, what is that volume doing? Well, the sign tells us what it's doing. The volume of the box is decreasing. Now we're always going to write this. At an average rate of, fourth thing, is the actual numerical value. Average rate of 154.580. Last, we look at the units. And I know this is kind of busy up here. The units come from this rate of change. What's the volume measured in? The volume is measured in cubic inches, so we're going to say inches cubed per inch because that's what the denominator is being measured in. From x equals 13.2 to 14.5 inches, the volume of the box is decreasing, at an average rate of 154.580, always 3 decimal places, cubic inches per inch. That's the sentence. This sentence is going to come up again and again and again in all the future units. So let's make sure we're getting it right. Okay, part E. We want to know for what values of x will v of x satisfy the inequality v of x less than 800. In order to do this, again, let's go back to the calculator. So I'm switching modes. Let's go back to the graph. The blue represents the volume at any particular value of x. What we're going to do, and this is something that you probably started doing in Algebra 1 or Algebra 2, we're going to graph another equation. We're going to graph the line y equals 800. The blue is the original volume. The red is the line y equals 800. And I want to know when the volume is less than 800. Graphically, what that means is where is the function below the line, below the red line. Another way to say that, where is the blue below the red? And let's keep in mind that we also have a domain restriction here of 0 to 18. What we're going to do is we're going to find the intersection point, because we can see that the volume is always less than 800 until I reach the intersection point. Then the volume is greater than 800 until I reach the second intersection point. So let's do this. Menu, Analyze Graph, Intersection, Lower Bound, so go to the left of the first root. Upper bound, go to the right of the second of the intersection. Darn it, I'm getting that issue with the 5.7. All right. So I'm going to go back to menu. Sorry about this. No, I want to go back to settings. Settings. I want to change document settings. Come on, fix. Okay, make default. Apply your settings to open document. Yes. Bummer. All right, well, I'm not going to let that stop me. I solved this problem earlier. I know from my earlier work that the exact value there is 5.7034. Sorry that I'm not getting this exactly right in the video, but the correct answer here to 3 decimal places is 5.703. Then we're going to go to Menu, Analyze Graph, Intersection. I want the second intersection, lower bound, upper bound. The intersection point here is 16.5, but I know from my earlier work that it's really 16.537. The blue function is below the red curve all the way until the root. So let's go back. V of x is strictly less than 800 on the interval 0 to 5.703, open parentheses, and then it happens again, so I'm going to use the U, 16.573 to 18. So on these two intervals, any value of x that I select will give me a volume less than 800 cubic inches. All right, now we're on the last question. I want to determine the dimensions of the box which generate the box with largest volume. Largest volume means the volume is going to be a maximum. Let's go back to the graph. Okay, the volume is going to be a maximum at this point over here. And I think we actually found that earlier, didn't we? We needed that to know when the function stopped increasing. Since I've just deleted it, we'll analyze the graph. Analyze graph, I want the maximum. Let's do that again. Analyze graph, maximum. Why won't it work? Menu, analyze graph, maximum. There's my lower bound. There's my upper bound. The maximum is at 12. Okay, so that 12 represents the x value. This 1.73 e plus 3 means 1.73 times 10 to the third. Again, I'm having some issues with my online calculator right now that I can't quite fix. So that 12 represents the x value. That's how large the base should be to create a maximum volume. This 1.73 e to the third is what the maximum volume should be. Well, let's go back and put this all together. We know from the graph that the maximum volume occurs when x equals 12 inches. Well, let's think about the box. That's 12 inches over there. That's 12 inches over there. What I'm missing is the height. And way back when we first started this problem, we had established the relationship that the height was going to be 36 minus 2 times the x value. We know x is 12. So the height is 36 minus 2 times 12, which is still 12. So the dimensions will be a length of 12 inches, a width of 12 inches, and a height of 12 inches. What did we just build? We built a cube of 12 inches on each side. If I wanted to know the volume, I would take 12 cubed, which is 1,728 cubic inches. That was being displayed on the calculator as the 1.73 e plus 3. Please don't write that as your final answer. And I think that does it. Again, my apologies for the technical issues with the decimal display on my computer. I'll be sure to get that fixed between now and the next video. I hope you found this helpful.